In this video, you will learn about Nomogram for Purifier, which is used to select the correct size of gravity disk for fuel with different densities. For selecting the correct size of gravity disk, we will need three things. Number one is specific gravity. This can be at 15 degrees Celsius or at any another T degrees Celsius temperature. Other thing is the temperature at which the fuel is to be treated and the feed rate, which is given to the purifier. By all these three, we will get to know the correct size of gravity disk which we have to use for that particular fuel. Now, this is how the nomogram for purifier looks like. On x-axis, we have treating temperature, the temperature at which we have to purify the fuel. On y-axis, we will have the specific gravity value. On this side, we will have the size of gravity disk, which will be the inner diameter of gravity disk. It will be in millimeter. And on this line, we will have the feed rate, which we will be giving to the purifier. So now we have to select this value, and we know this feed rate, treating temperature, and specific gravity. We can see that these blue lines are the rising curve. As the temperature increases, its specific gravity will increase, and these red lines are the falling curve. As the temperature increases, specific gravity decreases. So by two examples, we will get to know how to use this nomogram. Example 1, we are provided with specific gravity of treated oil at 15 degrees Celsius. Treating temperature is 70 degrees Celsius and feed rate is 3000 liters per hour. So in example 1, we are given with the specific gravity at 15 degrees Celsius, treating temperature that is 70 degrees Celsius and feed rate is 3000 liters per hour. The density is given at 15 degrees Celsius. Then we will be using this falling curve. If the density is given at some T degrees Celsius, then we will be using this rising line. Now we will have to select the size of gravity disk. For this, we have to use the given data. We are given the specific gravity at 15 degrees Celsius, which is 0.905. Now we will just make an intermediate curve in between 0.9 and 0.91. And the point of intersection of these two lines, that is the falling curve and this temperature line. Now from the point of intersection, we will just draw a horizontal line. It will till 100 degrees Celsius, that is the last line of this nomogram. And now we will check the feed rate, that is 3000 liters per hour for this one. So we will mark on the feed line 3000 liters per hour, and just we put the scale and join these 2 points. Now the point where this line cuts will give the accurate size of gravity disk which is needed. So suppose if the line cuts in this green zone, then we have to use this 80 millimeter inside the gravity disk. Now let us suppose we don't have the required size of gravity disk. In this case, which is 80 millimeter inside dia. So in that case, we will have to use the next bigger one available on board. But by using that bigger one, purifier might overflow. So to overcome that, we will just adjust the back pressure. Now let us move to the second example. The specific gravity will be given at temperature other than 15 degrees Celsius. So here it is given at 50 degrees Celsius, 50. Treating temperature is 98 degrees Celsius and feed rate is 1250 liters per hour. So now as we are given specific gravity at 50 degrees Celsius, we will just drawing a perpendicular line from 50 degrees Celsius. And the rising line, which will be coming from 0.944 specific gravity. Just make it intersect. Now we have to check the fuel treating temperature, which is at 98 degrees Celsius. for this one. So 98 degrees Celsius, we will be plotting a vertical dotted line like this. From 98 degrees Celsius, we will plot a vertical line. Just extend this line as long as possible, and from this point where the rising curve and 50 degrees Celsius, that is temperature at which specific gravity was given, that point we just draw a falling curve like this. And now the point where falling curve cuts the treating temperature line, that is 98 degrees Celsius line. From there we just draw a horizontal line to the last line, that is 100 degrees Celsius line for that nomogram. We are given the feed rate which is 1250 liters per hour. So we will just mark 1250 liters per hour on this given line. And now we will just join these 2 points, this one and this one. We just join these two. Now the point where it cuts the line, this one falls in this region. So this region we have to use 72 millimeter inside gravity disc. Now let us suppose that we have two fuel. Fuel 1 has a specific gravity of 0.9, and fuel 2 has a specific gravity of 0.8. If we keep other two things constant, that is treating temperature, let us suppose we are keeping at 80 degrees Celsius and feed rate 4000 liters per hour. So by plotting this line we get the size of gravity disk. We will get that for number 1 fuel, that is 0.9 specific gravity separation temperature 80 degrees Celsius. So for fuel 1, which is 0.9 specific gravity, we are getting the size of gravity disk is 43 mm. And similarly for the fuel 2, which is having the specific gravity of 0.8, separation temperature is 80 degrees Celsius and feed rate 4000 liters per hour, we find that in this case we get the size of gravity disk as 45 millimeter. So for fuel 1 we are getting 43 and for fuel 2 we are getting 45. This signifies that if specific gravity is decreasing, then size of gravity disk will increase.